So thanks for being part of this presentation, first of all. So before I start, I really like to do selfies. So if you could to have family pictures, if everyone could be there and smile, that would be awesome. Otherwise, the picture won't be fine and people won't see it properly. So, could you just smile, please? Thank you. That's fine. All right. So that's done. Now we can go to the presentation. So first of all, I would like to introduce myself. So who I am. My name is Henrik Raxed. I am a Swedish, so I'm a Viking. I come from the north. Winter is coming, in fact. And I'm a Lego fan. So if you combine both of them, that's bring me. So if you go to LinkedIn or to Twitter, you will find this gentleman, which is me. It's my my Lego fan, Henrik Rexed, the Night Loader. So I've been in the load testing since 12 years. I work for MoveIT as a technical evangelist, and I'm looking at how can we support the new stack, the new technologies, how can we bring value on IoT, on AI, whatever it is. So before we get there, so I don't know if you're familiar with our company. So I'm going to do some first introduction about who we are, and then we're going to go directly to the main topic. So Neotis, we've been in the market in 12 years, delivering only one thing, is one product to help our customers deploy their applications in productions in a performant way. So it's a load testing vendor. So I'm going to not talk about all the references, of course, because it would take too long. What I want to talk about is the way we've been building the product since the last 13 years. We're looking at the challenges around performance. And for us, the three main challenges are first, the user demands. I mean, we are a load testing solution, so we need to measure the response times. And if you look at the customers out of the market, they're really looking at performance. Performance is really important. It's one of the aspects of the user experience. And for us, we need to make sure that we are properly measuring the user experience, especially when you talk about mobile devices, mobile applications, especially when you look at the new frameworks where you have a lot of JavaScript rendering on the client side. And we need to figure out how to measure that properly and report it back to our product. So this is one of our challenges. The second thing is the way we deliver. I mean, we've talked about it a lot today. The methods, the way to deliver the projects, especially in the performance, it impact a lot the way we're working. So testing, bringing performance in those environments, we need to make sure that we bring the proper features to automate, to bring to test faster and more. So that's also one of the things that brings our product and the features is the process revolutions. And last is the technology. I mean, we are a technology company. We've been focusing on technology since the last 12 years. Our main goal is to support all the latest technology. If IoT is there, we have to support the IoT protocols and so on. So the idea is to be the first one supporting those technology, and we want to keep that leadership. So here, before we get to how to bring performance, how to collaborate and deliver performant application productions, I just want to first start with performance matters. I mean, I'm pretty sure that everyone agrees here. Here I've extracted a couple of references about the importance of performance for the end user experience. I mean, people using mobile devices more and more. They're reaching the application through their mobile device. I can see people doing that, in fact. And the expectation of the mobile users are bigger than normal browsers. And what is user experience? I mean, let's take a few seconds. First, you need a feature. I mean, you need a functionality. And if this functionality is not there, of course, the customer won't be happy. Then we bring some ergonomy, some accessibility to make it easier. You don't have to learn to have a training to learn to use the application. The idea is to make it very nice graphically. And last is the performance. One of the main aspects is performance. If the performance not there, then customer will be frustrated and unhappy. Last thing is performance impact the business. I mean, here, I'm not going to talk about all those references. If you go to wpostats.org, there's dozens of references. And what is funny here, 10 years ago, Amazon had a study proving that every time they were increasing their response times with 100 milliseconds, they were losing 1% of revenue. And if you look at the revenue of this reference of Walmart, which is last year's reference, it's funny because it's the same numbers. Response times impact revenue, and that's for sure. So even if you're not in the retail market or customer-facing applications, if you're bringing slower application, your user will be frustrating. They will won't be able to do as much transactions in a day. So that's performance is important. So this is sure performance is important. So let's make sure that we deliver good performance application to our users. So the key, we introduced this seminar with the evolution of the process. So I'm not going to go fast here and not talk about it again. But here, let's just think about performance. When we, as a performance tester, we used to be in the acceptance usually. So we were arriving very late on the cycle, and we were if we're detecting problems, it was obviously too late. And a couple of years back, even if you're saying, "Oh, the application is going to crash," people didn't care. They were just deploying it, and what happened? It crashed. Now performance become more important, which means sometimes you can block deployment. And that is good for us, at least for a performance tester. And I think performance tester, what is the difference between a performance tester and a performance engineer? And this is exactly with the cycle. The performance tester, you will be a performance tester if you don't influence your coders. A performance engineer has the ability to influence the next line of code in production. And this is our main goal as a performance tester. We need to become performance engineers. The second thing what I like to compare is how we used to do performance testing. So I don't know if you're familiar about that video games. So for those who doesn't know, it's Street Fighter. Street Fighter, if you remember, 2 fighter, 3 rounds. And sometimes you had that bonus stage, if you remember. So that car where you have to hit it. And I like to compare the way we used to do performance testing with the bonus stage. Why? Because sometimes you had that bonus stage, but it was unpredictable. Sometimes you have it, sometimes you didn't have it. So it's similar to that. So performance testing is like a bonus stage at that time. Next is performance testing was this bonus stage, and we required that nice and shiny application, so nice shiny car. So we needed to wait for that apps to be finished to start testing. And what is funny is performance people that would start doing performance testing, they didn't really know how to do it. So what they were doing, exactly like that fighter, they were hitting the car, bah, bah, just to get some points. But at the end of the day, okay, you break the car, that's wonderful, you get some points, but what did you prove? Are you able to go to production with that car which is just crashed? What did you prove, in fact? And this is the most important aspect, is performance strategy. I mean, performance design or performance strategy is the main aspects. And I like to compare it to the Tacoma Narrow Bridge. Tacoma Narrow Bridge, I don't know if you're familiar with that bridge. It's a bridge nearby Washington. So it's opened in April 1940 and collapsed 4 months later. So what is the relation in performance? You will see. They had 2 requirements. The first one is the capacity of handle heavy load on the bridge, cars. And the second one was the capacity of handle strong winds. And the funny story about it is they have tested that. So one day, they put all the cars on the bridge and trucks, put some measurements, and they say, okay, good, we support heavy load. Then they say, okay, we have to test now with strong winds. So one day with the heavy winds, what they put some measurement, no car on that bridge, and they say, okay, good, fine, we support strong winds. So 2 requirements respected. But what happened when it collapsed? It was simply the combination of heavy load plus strong wind. And it's the same thing with performance testing. If you don't take all the requirements, all the impact, all the load that could happen on your system, then you won't prove that the application will be stable and performance in your production. So that's important. Performance strategy is the most important step when you want to deliver proper load testing. Second aspect is, this is the standard workflow when you want to deliver load testing. This is true since 10 years. First, you build a strategy, then you record your scenarios, you correlate them, you make it randomized. Then you prepare the environment. Prepare the environment is having a proper architecture for your testing application, also the proper architecture to generate the load. And then you apply the monitoring. Monitoring, Remember that. Because I've seen a lot of projects that do load testing without monitoring. I like to compare load testing without monitoring is like listening to a horror movie in the radio. You will hear people screaming, but you don't have the picture. So it's going to be very scary. So you're testing, so please put the HD color screen in front of your eyes, understand what happens, and then you can correct and resolve the problems. Then you're going to execute, so all the tests that you have defined to prove that your application is able to support the load. You execute them, you analyze, and then you tune. Two level of tunings. First one, configurations, on the bringing caching layers, whatever it is. And then, if it's nothing can be improved, it's going to be on the code, so improve the code. So now we want to test as early as possible. At the beginning we talked, if you detect an incident too late, it's going to cost a very lot of money. So we want to bring performance as early as possible. So to do that, there is a path to do. So first, risk analysis. If performance impact your business, so it's going to be a risk. So we have to bring performance as one of the risks of the project. And I would also recommend to look at ATAM, architecture trade-off analysis, which means every architecture design needs to answer a risk. So if you pick Windows in your environment, you pick it not because you have a gold support with the Windows, you pick it because you're going to resolve one of your performance requirements. Then we're going to test, so we're going to automate, because of course there are going to be a lot of things to test, so we have to automate to make it faster. And then we're going to validate, so bring KPIs that we're going to follow on a daily basis. And last, we're going to monitor. Monitoring in production, we need feedback. So Dynatrace here comes in the story. So let's build the strategy around performance. So first we have to ask us the proper questions. Where is the load coming from? Of course it comes from the users, but it could also come from third-party systems, from messages, from batches, a lot of things. We have to understand where this noise comes from. Then we need to ask us the proper questions. What are the users? Where are they located? Do they have any network constraints to reach my applications? Is there any marketing promotion plan? And so on. The idea is to figure out what should I test to prove that it's going to be working efficiently. Then we have to build up the scenarios. To do that, there is two types of application. Existing application, so it's history. We have a lot of data. We have tracking systems. Marketing is putting Google Analytics. We have logs. We have a lot of things in a database. So we can build a really realistic model based on that. That is really comfortable. The other one is new applications. It's pure science fiction. We don't know where we're going to head to, so let's explore how it behaves, how it scales, and then we're going to adapt the load policy depending on when we deploy the first release in production. So how do we bring performance as early as possible? Simply by testing small things. So component testing, unit performance testing. There is a lot of different names in the market, but today we're going to call it unit performance testing. The idea is to test your main components. You know that in your applications you have dozens, millions of components, but there are a couple of components that are the heart, the legs, the arms, the brain of your application. So let's test them on a daily basis to make sure that they are stable and they are providing good response times and robust enough for production. So the idea is here, the advantage is the test cases, the test scenarios are simple. Maintenance is very low, and you can test any system. And also, if you buy any third-party components for the payment or whatever it is, you can test it separately. You can make sure that it will behave properly in your network. So how do it work? First, we start with the specification. So what are the main meaningful use case that will be used by my users in my production? So that's the first thing. Then I translate those into components, retroengineering. So here in my example, I have the red components, the gray, and the green components. Then I plan my sprints, sound out pretty well when those components will be ready. And then so we have the first sprint, we have the red components ready. I will build one load test for that components. I add that in my CI/CD process or pipeline, and then I trend that on a daily basis. Second component is ready, which means in my building process I have two components, two tests, trending two performance behavior for those two components, and so on and so on and so on. And the idea I won't limit myself to only testing the components, of course, because I need to make sure how it will react when I start to connecting those components. Will there be the performance there still, or do I have any regressions? And for testing components, the main thing here is the complexity. If you look at the represented application, you have millions of components everywhere. And when you have to test something and you say, okay, let's test around 30 components, that will be representative. The thing is, the main problem is that those components are dependent to each other. So which means if there is someone doing a maintenance or there is a new release of that component, I'm not able to test. So I'm blocked. I'm not able to train the behavior of that component. That's why service virtualization makes sense. There is a lot of products that will help you to do that. So service virtualization is one of the main aspects for that. So for that, we have to change mentality to bring performance. We used to do rate, record, playback approach. We need to bring it to early performance engineering. We used to do SLAs on response times. We're going to translate that in SLAs in components. We used to do black box. We didn't know really what's happening in that box. And now we're going to do gray box because we know for sure which components, which API are used by the application. So what is the difference? So that's for Agile, but for DevOps, it's exactly the same thing. In fact, when I talk about DevOps, what I prefer to say that, okay, it's good to have to deploy a lot of releases in productions, but if the quality is not there, it doesn't make sense. If you have the best car in the world, but if you don't know how to drive it, it doesn't make sense. And in DevOps, I prefer to name it Dev Test Ops. Test is one of the key steps of DevOps. Otherwise, it would fail in production. So, our product NeoLoad, we are using our product either in dev, so to test the components on a daily basis, so to automate this by plugging with the CI/CD engine. So here with Jenkins, with Bamboo from Atlassian, we plug it as well. So you can follow and trend the performance. We're not asking you to analyze every testing results. The idea is to trend those results and detect regressions. That's the main idea. The second thing is when we deploy everything, all the components together, then we need to make sure the user experience. So we're going to trend how the application reacts when we generate load from the cloud, from the mobile device, including network, and so on. Here, this is a typical example of a pipeline where here we have Bamboo that will orchestrate the entire pipeline. And the code here is stored in Bitbucket. We build the application with Maven because it's a Java-based application here in our example. We do some cross-code analysis. We deploy in Docker in different environments so we can test in parallel the performance. And then our solution is Docker compatible, which means you can imagine a full dynamic load testing architecture based on Docker. So we can have a step in our pipeline where you spin up your load generator container. And then we will take advantage of running load tests against the components. And here, the integration of Dynatrace makes a lot of sense. You can prove exactly what happens in the back end. Why do we have some slow response times? And then when we do the end-to-end testing, of course, we're going to do functional testing first. So RunOX will be there. We can combine with YSlow to measure the web performance. And then we're going to go there next with testing the overall application. I think I'm running out of time. I wanted to talk about APM to conclude, because if you test on a daily basis the components system-wide, I mentioned it, you need to monitor your applications, and you need to adapt your testing strategy depending on the load that you've seen in production. So APM is more than required if you go on DevOps. So here, normally APM has 5 dimensions. I will just reduce them to 3 dimensions. So first, the user experience. Second is the application instrument, and then proactive monitoring. So we're going to explain it shortly, those 3 dimensions one by one. The first one is, okay, I want to make sure that my application is running on a daily basis, 24 hours, 7 by 7. So for that, synthetic monitoring is the solutions, because you don't need users. It's going to be a robot that will simulate the users. So if something crashed at 4 a.m., even if you don't have any users, you'll be alerted through that robot. But then you need to figure out about user experience. So RAM is also more than important. So here, every user will report how they're using the application and the performance on a daily basis. Last, I need to figure out what happens in the background, the service flow. So I need to set up one agent, for example, that will help me to figure out where I'm spending time and what should I do to make it better. And I will leave, go back, and I will leave it for my colleague. I'm sorry I took so too much time, but that's yours.
Sorry, I knew it was risky. Is this working? I knew it was risky talking after this guy. So it's true. I knew. I don't know how much time have I got left. 8 minutes, right? So I wanted to give you a bit of perspective. As you've understood, Henrik is really talking about a new way of thinking performance testing. I don't know in your organizations, but today, let's say QA in general, everything that has to do with quality and performance especially is considered or perceived, at least as a bottleneck, right? This is generally the heat that all you guys are feeling, especially those that are doing performance testing. So I think really things are changing fundamentally from the DevOps messaging, obviously, but in general, okay, and as Henrik said, right, I think the performance engineer is going to be there for a long time. His role and the way he's thinking about his job is changing, right? He's not the guy who's raising issues. He's not the guy who's just pointing to problems. He's becoming the guy who's providing solutions. I think that's the real fundamental way to go as a performance engineer today. So I just wanted to make most of those few minutes I have to be very short, but I wanted to give you a perspective on our axis, how are we thinking we're building our features and our products. We're agile, so we have to put those features into perspective. Each release that happens every 9 weeks, okay, is a set of releases that make sense, but especially if you get an idea of the whole story. So the axes we're building on, and I think you can relate them to everything that's been said by Henrik. The first one is CI/CD and CI/CD in general, everything that goes with continuous integration, continuous delivery. That is essential. Back to the perception of performance testing being a bottleneck, right? That is absolutely essential to make that perception change. And automation. Automation is of the essence. If today you cannot automate your test, in general in QA or having to do with performance testing, it's not going to work out. And I'm also referring in automation to one very important point that we often sort of forget, okay? Yes, we've got to automate our test, but when the application that is being tested changes, how does that maintenance happen, right? And this is somewhere where we really are concentrating our efforts. Today, we are capable of redesigning actually your existing scripts. When I say redesign, it means that if your application under test has evolved, has changed, okay, you're going to re-record your test, your script test. We're going to compare those differences, and we're going to generate, most of the time, 95% of the time, we're going to generate a new test that most of the time you don't have to touch again, okay? It will work for your new version of the application. Is that my time up? That was bullish. Okay, sorry. Component API testing, that's the second axis. It's fundamental. And is it working? Yeah. Component testing, so shift left, yes, definitely, right? This is a big change. Today, traditional performance testing happened on system-wide testing. It happened at the end of the cycle, just before going to production. It makes sense in terms of non-regressive testing to do it early, and I won't explain, I'm sure you're all convinced of the value of this. Platform openness, I think that is essential as well, right? When I'm thinking platform openness, for us, it's saying today the way you're thinking of the tools you're going to choose is best of breed. You're saying for QA testing, I want that tool. For performance testing, I want that tool. You're going to integrate those tools that are best for you. Okay? This means that from our point of view, you've got to make the choices you decide on and integrate. Obviously, we're going to make it easy to integrate with tools that we consider as valuable. Okay? So I'm thinking Dynatrace, for example, but we're agnostic. But yeah, we are really working on our integration with Dynatrace. RunnerX is for one, okay? And I'm not just here because today RunnerX was here, okay? We're going to go on a deeper integration with RunnerX because we've got customers that are asking for more integration with RunnerX. And then core load testing, obviously, because that's the heart of our tools. Very quickly on this one, it's just to give you an idea. I'm not going to detail those features. It's just to give you an idea of how, when you're going agile, you're working on your axis and you're telling a story. So we're building features little by little on component testing, platform openness, CI/CD integration and automation. I just want to end on this slide, and this will give you a little bit of perspective on our roadmap. You'll see there Dynatrace integration. We already have one. We're going to go further on that integration. And okay, maybe at the booth you can come and see us so that you get a more detailed idea. I haven't got the time to detail that. We've got a RunnerX integration that's heading for Q2 2018. Now the big things otherwise on our roadmap is Q1 SAP integration, which means you'll be able to do performance load testing on your GUI, your SAP GUI applications, okay? And then for us, it's essential. We have Nearload Web, which is a centralized, it's part of our platform. It's a centralized point where you can actually get all your test results into there so that you have that centralized place where you can go, share, cooperate on the results. In Q2 2018, you'll be actually able to run your test from that platform. So you'll design your test on your laptop. Once your tests are okay, you just throw them on Nearload Web and you'll be able to execute your test from that centralized platform. By the way, Nearload Web has a SaaS version and an on-premises version. And then 2018, so probably, okay, let's be transparent, end of the year, we're going to integrate with JMeter, meaning we're thinking open source, probably shift left as well, but we want you to be able to, if you have JMeter scripts, to be able to run those scripts inside our tool. Right. Thank you. I'll stop here, and if you have any questions, in the time.